Hello students, today we are going to discuss about the representation of negative numbers in binary system, 1's complement and 2's complement. So these are very important topics under the chapter number 2. Okay. One important representation of negative numbers is using the sign magnitude representation. So let's see what is sign magnitude representation. In sign magnitude representation, the most significant bit means the leftmost bit or digit position. The most significant bit position is used to represent the sign of a number. If the most significant bit is 0, that means that number is a positive number. If the most significant bit is 1, which means that the number is a negative number. So here you can see that two numbers are given, plus 7 and minus 10. So plus 7 and minus 10 are given. So what we have to do, if you look into the binary representation, the most significant bit of plus 7, it is 0, and most significant bit of minus 10, which is 1. That 0 and 1 denotes whether the number is a positive number or a negative number. Okay, so please see the examples of plus 7 and minus 10. I hope you understand this. Okay, now we are going to see what is a 1's complement. So the 1's complement of a binary number. So what is a binary? What is a binary number we know. So here we can see how we can find 1's complement of a binary number. It is quite easy because 1's complement of a binary number can be found by replacing every 0 with 1 and every 1 with 0. Let me repeat. To find the 1's complement of a binary number, we can replace we have to replace every 0 with 1 and every 1 with 0. Every 0 with 1 and every 1 with 0. Okay. So please note that we always find the complement, 1's complement or 2's complement. We always find the complement of a negative number only. The reason is that in 1's complement, positive numbers need to be in its original form, right? Only the negative numbers are represented in the complement. Let me repeat. In the 1's complement, positive numbers should be represented in its original form, and only the negative numbers are represented in the 1's complement. Okay, here we are going to see about 2's complement. Okay, so what is a 2's complement? We have already seen what is 1's complement. So if you know 1's complement, what is 1's complement, then it is easy to find the 2's complement. The reason is that to calculate the 2's complement, you have to add 1 to the 1's complement. Suppose if you want to find the 2's complement of a binary number, first you can find its 1's complement. After finding the 1's complement, what do you have to do? You have to add 1 to its 1's complement. Okay. So again, here also we can say we always find the complement or 2's complement of a negative number. So in 2's complement form, the positive numbers are always in the original form. That means we are not making any changes. But when it comes to the negative numbers always represented in 2's complement. Okay. Okay, here is an example for you. here we have to find the 1's complement and 2's complement of two numbers. First we can see we are given with a number -7 or -7, right? And here on the screen you can see that we are using the sign magnitude form. That means sign magnitude form, the leftmost or the most significant bit should be assigned for the sign. So here you can see that MSB or most significant bit is 1. That means it is a negative number, and rest you can see it is the binary representation of the number 7. Okay, now look into the 1's complement of the 1's complement form of -7. So 1's complement, what we do, we replace all the 1's with 0 and all the 0's with 1. So here you can see that, as you can see, the 1's complement form of -7, it is written there, right? And here you can see that it's 2's complement form. 2's complement form, there is only one digit, you are adding 1 to the last bit, then you are getting the 2's complement. So on the screen you can see that we have -7. -7, we find the 1's complement by replacing all the 0's with 1 and 1's with 0. Then if you want to find the 2's complement, add 1 to the 1's complement of the number, then we will be getting the 2's complement. Okay, now we can see how we can use this 1's complement or 2's complement can be used to perform some operations on binary numbers. Let's start with the 1's complement, right? So here we can see how we can make use of this 1's complement to perform some operations on the binary numbers. So we are performing the subtraction. Using 1's complement. After learning the subtraction using 1's complement, we can learn about subtraction using 2's complement. So this topic is very important. Please listen carefully. Okay, so here we are going to see the subtraction using 1's complement. So when we perform the subtraction of two binary numbers, we know that we always find the complement of a negative number. Right? Okay, now we are going to see 3 scenarios. So 3 scenarios means when you perform the binary subtraction. There are situations like, for example, +7 -3. So we have a +7 and -3, which means that the positive number with a higher magnitude. Let me make it more clear. What is positive number with a higher magnitude? So we have, for example, we have +7 and -3. So if you take the absolute value of +7 and -3, we'll be getting 7 and 3 respectively. So here we can see that 7 is having higher magnitude because 7 is greater than 3, right? So here this is an example of positive number with a higher magnitude. That means we were provided with 2 numbers. Out of that, the positive number is having higher magnitude. The second scenario is, suppose if we get a question like -7 and +3. So here we can see that 3 is having higher, 7 is having negative. So it is an example of negative number with a higher magnitude. So -7 + 3. So we can see that here the negative number is having the higher magnitude. Then another situation is when both numbers are negative. Okay, so let me repeat again. So we always find the complement of a negative number. So we can have a situation positive number with a higher magnitude, for example plus 7 minus 3, and we can have minus number with a higher magnitude, that is minus 7 plus 3. When both numbers are negative, that is minus 7 minus 3. So let's see how we can make use of 1's complement to perform subtraction operation in these different situations. Okay, let's see our first category, that is positive number with a higher magnitude. So I am giving you the same example, that is plus 7 and minus 3. So here you can see that the positive number is having the higher magnitude. So let's see how we can perform the subtraction using the 1's complement. Here the steps you can see, we are provided with two numbers plus 7 and minus 3. The binary equivalent of plus 7, you can see that have represented there. So plus 7, we are using the sign magnitude form. The bit which is separate from that group, 0 stands for positive. So 0 0 1 1 1, which is the binary equivalent of plus 7, and for minus 3 I have written 1, which means that is stands for negative, and 0 0 1 1. Okay, so we are going to work on the principle. First we are going to find the 1's complement of a negative number. So here the negative number is minus 3, and the 1's complement of minus 3 we will be getting by replacing each 0 with 1 and each 1's with 0. So the 1's complement of minus 3 is 0 1 1 0 0 0 1 1 0 0. Okay, and after finding the 1's complement, of the negative number, what we have to do, we have to add with the positive number. So here we are performing the operation, that is plus 7 plus 1's complement of the negative number. That is, here you can see that I am performing that step. So 1 plus 0 it is 1, and again 1 plus 0 it is 1, and 1 plus 1 it is 1 0. So 0 I am writing there, carry on the top of that 0, you can see that is in the red color. Okay, so when you add 1 plus 1, again it is 0, and please note that an important thing here it is an extra carry is generated. A carry is generated, but we are not adding that to the sign bit. Instead, that carry generated is added to the least significant bit. That means the last digit or the rightmost digit in the intermediate result. So we will be getting the answer as 0 0 1 0 0. If you look into this, you can see that which is equal to plus 4, that is the desired result. Whenever you got a question like this, plus 7 minus 3, you will be getting an answer plus 4, right? So here in the using the 1's complement, we have proved the same, that is okay. Please note that whenever there is a carry, you have to add that carry to the least significant bit. So here you can see an example. We have two numbers, plus 5 and minus 4. So plus 5, the binary equivalent of plus 5 is written there, and the binary equivalent of minus 4 also we can see there. So what we do, we need to find the ones complement of the negative number. So here it is, the negative number is -4. So we find the ones complement of -4. Ones complement of -4 you can see on the screen, right? After finding the ones complement of -4, we need to add with the positive 5. So here that is what we are, that is what you can see on the screen. The binary equivalent of 5, it is 0. That 0 stands for the sign. Then 0 1 0 1. Ones complement of -4, it is 0. Then 1 0 1 1. When you add 1, so we can start the calculation. So when you perform 1 plus 1, it is 0. We have a carry there. So again 1 plus 1, it is 0. Again we have a carry. Again 1 plus 1, it is 0. Again carry 1. So 1 plus 1, it is 0. And if you add, so the extra carry is generated, that we are adding to the least significant bit. So it becomes 0 0 0 0 1, which is equal to plus 1. That is the desired result. Okay.